In example number 3, we're going to be now graphing an exponential function when a now is in between 0 and 1. So it's going to be a rational number in between 0 and 1 and not equal to 0 or 1. So let's go ahead and kind of see what this looks like. And so last example, we saw what happens when a is in between 0 and 1. And notice how it rises from the left to the right. But now let's go ahead and see what happens when it's something else here. And let me just go ahead and put this in between 0 and 1. And we'll go from there. Good. So notice now when it goes in between 0 and 1, it looks the same as the other one, right? Just kind of reflected across the y-axis. So I'm just going to kind of go back and forth there so you can kind of see that. Well, look at that one. It's pretty close there to almost being a flat line. And actually, when it becomes 1, it is a flat line, right? Why? Because 1 to the power of anything is just going to be 1. So this is what our exponential function looks like when a is in between 0 and 1. Right? So we want to know what does the graph look like when it's 1/4, right? Because that's what we're graphing right now. And let's go ahead and make a little chart here. Bam. This is what it's going to look like. And what's neat here is that when you go to the left now, the negative x values, you're going to get bigger numbers here, right? Because when you plug in -1, so 1/4 to the power of -1, that just means that we are taking the reciprocal of that. And like I'll show you on the other slide here how that works as well. This is what our graph's going to look like. And so let's just graph this by hand as well, right? Because we don't always have this powerful tool to use Desmos, which I'm not sure why we wouldn't not want to use it, but sometimes we have to graph these things by hand, and so let's go ahead and do that. So if we're going to graph this guy without a cool calculator, we're just going to go ahead and plug in a few values. So like for instance, if I'm going to start at 0, the x value is 0, well we know that that's going to be 1. And every exponential function has a y-intercept at 1, right? That's what's pretty cool because when you plug in 0, anything to the power of 0 is 1. But now what happens when x is -1, right? So 1/4 to -1, and what that means is we take the reciprocal of this, right? So that's 1 over 1/4, which is just simply 4 over 1, which is why it's going to be -1 and then 4. And say if we wanted to do 1/4 to the power of -2, well again, that's going to be 1 over 4 squared, which is the same thing as if you just want to flip this now. I mean, you can, but I mean, we can wait. You can do 1 over, and that's 1 over 16, or just 16, right? So what I meant by that is like you can flip that here now, right? I mean, you can just say, oh well, this from here that just means 4 over 1 squared. And that's how you make that from a negative exponent to a positive exponent, which is just 16. So this actually maybe be a little shorter here and may make more sense right here. So of course that's going to be something way up here, right? And then of course, the little fraction ones is really kind of hard to really graph unless you're going to make your y value increments by quarters or something like that. But basically it's going to look something like this. And again, my drawings are horrible on this, right? I mean, trying to draw like on a slate doesn't always work, but that's why we'll rely on something like this that works out pretty well there. Okay, so what's important is just to know is that when the graph is between 0 and 1, it's always going to be going from left to right, which the asymptote will be going down to the right. And then when a is bigger than 1, then it's going to be going the other way just like that.